This is the homework helper for the 8th grade elimination method worksheet. We'll take a look at questions 3 and 4. Let's start with number 3. We've got 4x plus 5y equals 14 and negative 4x minus 3y equals negative 10. Remember, when you start, what you need here is you need one set of the variable terms, either the x term or the y term, to be like in terms of value but opposite in terms of sign. And as you can see here, in the top equation we have 4x. In the bottom equation, we have negative 4x. So that means we've satisfied that requirement, and we can go on the process of solving here. So once we have that accomplished, what we want to do is start the actual canceling out procedure of the elimination method. What we're going to eliminate here is the x. All right? Remember, when we do this, we sum vertically. So I'm going to do 4x plus negative 4x. Well, that's not going to leave me any x's. Those are just going to wipe each other out. So that term just totally cancels out. I've got 5y and negative 3y. That's going to go together to give me 2y's. And I've got 14 and negative 10. That's going to go together to make 4. So I've got 2y's equal 4. Well, if 2y's equal 4, then that means y must equal 2, because 2 times 2 is 4. All right, so we've solved for one variable. Now what you want to do is take that solution and plug it back into one of the original equations and solve for the other variable, which is in this case the one we eliminated, x. It doesn't matter which equation you plug it in for, it's going to come out with the same solution, and it's probably going to be about the same amount of work since these equations look to be the same length. So let's pick this top equation here. I've got 4x plus 5y equals 14. And what I'm telling you here is that y is supposed to change into 2. Change that into 2, it's going to say 4x plus 5 times 2 equals 14, or 4x plus 10 equals 14. Well, that's just solving an equation at this point to find x, and then we'll be done. Well, we know if we're solving an equation, we send numbers off to the right, which means 10 is going to have to go to the other side. Variables would come to the left, but the only variable thing we have is already on the left. So I'm going to move 10 by using the opposite side to the opposite rule, knocking 10 off both sides. Do that, and I have 4x equals 4. And of course, if 4x equals 4, that means x has to equal 1, because 4 times 1 is 4. So our solution here is 1, 2. All right, let's go ahead and take a look at number 4. In number 4, we've got 2x plus 3y equals 7, and x minus y equals negative 4. Now this question is different than the previous question because we don't have any of the variable terms like in terms of the numbers in front of them and opposite in terms of sign. We do have a set here that's opposite in terms of sign. If we look at these y terms, this has got plus in front of it in the top one and minus in front of it in the bottom one, so we're kind of there. But the problem is the top one says 3 and the bottom one has an equivalent of 1. So we have to learn how to fix that. Well, the way you fix that is using one of the rules that's on the sheet that says you can multiply an entire equation by any number you want. You can multiply both equations by any number you want to come up with an equivalent expression, kind of like an equivalent fraction type of idea here. So what I want to do is, since I'm going to try and make 3y to match up here, I'm going to multiply this whole bottom line by 3. Again, you can pick any number you want. You can multiply the top equation by something. You can multiply the bottom equation by a different something if you need to. All right, but I see that if I multiply this entire bottom line by 3, I'm going to get what I need. So if I do, now when I multiply this through here, I've got to multiply every part by 3, not just the part I need. Every single part has to get multiplied by 3. Again, think of me trying to write an equivalent fraction. I can't multiply the denominator by something and not the numerator. Same idea here. Right? I'm trying to make this into a 3, but I have to multiply this by the 3 as well, both of these. So I do that. 3 through to the x, well that's easy, that's 3 x's. 3 through to the y, it's going to give me 3 y's. And 3 through to this negative 4 is going to give me negative 12. Now the top equation, I don't need to do anything to the top equation, so I'm just going to rewrite the top equation. So now I have 3x minus 3y equals negative 12, and I have 2x plus 3y equals 7. We'll look at these two y sets in the y terms there. The One is 3y, the other one is 3y. One has minus in front of it, one has plus in front of it. That's exactly what I need. That's exactly what I'm supposed to do. So those guys cancel each other out because I would add those up. That's the elimination part. Again, I'm going to add the other stuff vertically as well and solve the result. So I've got 3x's plus 2x's is going to give me 5x's. And negative 12 plus 7, which is going to give me negative 5. Well, if 5x equals negative 5, that means x has to equal negative 1, because 5 times negative 1 is negative 5. All right, so again, now I'm going to repeat basically what I did with substitution the other day. I'm going to pick an equation, plug in x equals negative 1, and solve. You can pick either one of these equations or either one of the modified equations for that matter. I'm going to pick this one here that says x minus y equals negative 4 because it looks like it might be kind of short. So I've got x minus y equals negative 4. We've just figured out that x is going to change into negative 1. So it says negative 1 minus y equals negative 4. Well, solve the equation. It said the numbers to the right side, which means I'm going to add 1 to both sides here. So I do that, and I have negative y equals negative 3. Well, that's not too far off, but I don't want negative y. I want positive y. Remember, when you have the opposite, you're going to go ahead and change the signs. So I'm going to run all the way across and change all the signs. Positives become negative, negatives become positive, which means in this case y equals 3. So I've got negative 1, comma 3 as my solution.